Now that you've learned about blockchain in application and as it pertains to IoT, it's time to put some of that knowledge to work. In this exercise, you'll discuss blockchain in application and with IoT. You'll explain proof of work and proof of stake, describe smart contracts, explain the steps in a blockchain transaction, describe the types of blockchains, and explain how organizations can use blockchain to secure IoT. At this point, you can pause this video and answer these questions. When you're done, resume the video to see how I would answer them. Okay, let's answer these questions. It's okay if you didn't answer them the same way. First, explain proof of work and proof of stake. Well, both provide distributed consensus, but the difference is that proof of work, which is typically exemplified by Bitcoin, is expensive in the sense of computational problems. The first user to solve a problem validates the transaction and is added to the blockchain, and the miner receives a reward. Now, proof of stake, which is exemplified by Ethereum, is similar to proof of work, but the difference is that the winner is selected using deterministic methods, things like randomness, age, and wealth, and the miner is paid in a transaction fee. Next, describe smart contracts. Well, unlike Bitcoin, Ethereum can store other information on its blockchain. So the smart contracts are used in part to eliminate the middleman, things like lawyers and notaries. And it can store anything of value, so properties, money, commodities, equities, you name it. And the contracts themselves define the agreement, so the terms and the penalties are actually baked right into the smart contract that's on the blockchain. And it automatically binds parties to the contract, and transactions with smart contracts on the blockchain are instantaneous. Next, explain the steps in a blockchain transaction. Well, when someone wants to purchase or sell bitcoins, they access a Bitcoin exchange and the transaction is requested. The sender makes the request, which is signed by your private key, and the request goes to the recipient. At this point, a digital signature is created using your private key and the transaction detail, and the request is propagated to all the nodes in the network. The nodes compete to solve the problem they've been given using a method like proof of work or proof of stake. The first node to solve the problem then broadcasts its results to the network, and nodes validate the solution. Once consensus is reached, that is, more than 50% of the network agrees on the solution, the transaction has been validated, and the transaction becomes part of the block being added to the blockchain. The new block includes a hash that matches a hash in the previous block, ensuring that this block is valid. At that point, the recipient now has the Bitcoin, and it no longer belongs to you.